moving into unit, so we're looking at different sections. We're looking at the what cost estimation is. We're also looking at various available estimation methods that we can use, what is the benefits thereof, how it's applied, and then we're going to end off with building information modeling. I'm just going to add on some information on that. In our first lecture with the residential students, we actually spoke a little bit about it because we've been using it already without really realizing it. It's just the method that we've been using that differs in the actual application of the technologies and so on. So we're going to just touch on that a little bit later on in this unit. So the introduction to estimation. I'm just going to run through a couple of things, and we looked at the tender document in class, and we established that up to the point where we actually receive a quote from the contractors, everything is still a estimate up to that point. Even the quotes or the tender prices that you receive is still subject to change as you go through the project and the project life cycle. So it is very much up to that point still a estimate that one looks at. So just the basics of estimations, and you will see this is a scenario that I've sketched here. So if you put yourself in the shoes of the QS or the CM on a project, you can ask these various questions. I'm not going to go into this as it is provided in the actual PDF lecture that was posted on Blackboard. But you basically have your advice that you have to provide to your client. You have to look at the size and the quality and the preparation and budget of your cash flows that you need to prepare for your client, and the construction program that's based on that. You have financial feasibilities that you also have to look at. And what we discussed is why we use this different estimation methods is really dependent on the amount of information that we've got available. So you're not going to start preparing a BOQ in stage 1 of your project life cycle because you don't have the necessary information on the type of finishing, etc., to actually get your descriptions up to a point where you can include it in the BOQ. So other basics that we have to look at is estimation of cost of the building project is done by determining the following. There is not sufficient detailed information available about the final design. So you can't do a design or an estimate if you don't have ample information on that. So obtaining the exact information can take some time. So in the past, I have done that before, where a client has asked for estimate and you were only supplied with sketch plans, and then one would make some assumptions on it, although that exposes you to actually whether you including all of the information. So where it depends really on where you are. So if you're working within a company, for instance, engineering company, or in a design company, you can actually ask for some of that details within your company. Otherwise, you can ask the architect or the structural engineer or some of the civil engineers to provide you with some information that you can work from. So for instance, if you can work per cube and then a rate of the reinforcing that is actually applied, so it would be in the range of 120 kilograms per cube of concrete, for instance, for reinforcing. So you can include items like that, but that is really subjective to what information the consultants can provide to you. Hence, we do use the single price methods, which includes all of these or this information at early stages of the project. So the client requires a cost estimate prior to the inception. So we need to provide a cost estimate to the client, and usually we use a square meter cost estimate, or we use a unit price whenever we do these estimations at the very early stage of the project. So the QS and CM should be appointed either before or at the same time as the architect, because as we've learned in our first and second years, 80% of our cost, plus minus, is usually established in the first two stages of our project. So the more influence you have on the cost on the early stage, the better you can control the cost as the project is designed. So early advice makes it possible for realistic estimates. So or if you look at houses that has to be built, the clients are usually not that well informed, and usually they start with a small house, and a lot of items are added as you go along. But if you are involved early on, you can state, but for this type of development, this will be the maximum size of the project. This type of site layout or site only will have a higher rate per square meter, for instance, for the construction, and hence you can put certain parameters on the design that it cannot exceed this size or so, then allowing for the external works that is usually excluded in these early design discussions. So the QS assists during the design stages to ensure that the design meets the employer's financial requirements. That was what I was talking about just now. The cost of the project is estimated by the QS and submitted to the employer for approval. Okay, so you will see in the fee scales for the QS, there's always a cost estimate connected to each stage. The construction project managers will see that the emphasis usually falls onto the signing off of each stage. So the client actually signs off of the designs, the appointments, the estimates, and so on. So the project management side of it is that the client was well informed on the design, this will be the cost, and then it was actually signed off. So the client cannot turn around later on to say, but this was not what he envisioned. So it is always very important to be very transparent in all of the discussions. So preparation of cost estimates and provision of such other cost advice as may be required at the draft design stage. The preparation of elemental or other standard forms of cost planning, design, developments, estimates, or budgets may be part of the documentation stage. Okay, we are all well aware of that. Thus, the QS can give preliminary cost advice at the commencement of the project and even before the draft designs are prepared. So you can get quite far with just the occupation layout from the architect. If he provides you with a square meter area, what type of project you're looking at, what type of finishes you're going to have, you can already provide the client with some sort of budget that they can aim for. So the cost advice assists the employer in making valuable decisions early on in the project. So your accuracy of the estimates is very important. What type of rate historical data will you be using? Will you use the same rates that applies to Cape Town, for instance, in Bloemfontein, which will not be the case because the standard building rate or the market differs from here to there or anywhere else in the country. Certain areas might be cheaper, or certain items might be cheaper in certain areas because it's manufactured nearby. If you're working, for instance, in the Northern Cape on the mines in the Kuruman area or so, you will have to take into account the transport costs to that areas and so on. So your accuracy of the estimate is very crucial for your designs. So it makes so you're putting your professional opinion out there of what an item would be and you want to try and be as accurate as possible. So what it means sometimes is you have to anticipate what the client actually wants without already stating it. For instance, if you're working with the office building and no one really thinks about the ICT or the access control installation or so, you should be in a position to think about those items that hasn't been thought of by all of the design team at that stage, um, because you will have to incorporate that later in your design. Unfortunately, the only real thing that assists with this is experience and working with someone that has worked on similar projects before, um, who can identify the possible risks of items being omitted at that stage. Okay, so many of these items you already know, but items that do influence your cost estimate is the stability of the market. Think about the fuel prices that's going up at this stage, inflation going up, um, the cost of getting loans for clients building a home or so. The time available, how much time do you actually have to spend on this estimate? Training, experience, knowledge, and estimator, knowledge of the estimator. So what I was just talking about of experience of whether these items were included or not. And then you've got your accuracy of your information from the estimator. Has the design team thought of everything? And the interpretation of the information. What does it mean to you when a structural engineer says, but because of the soil circumstances, we will not use 120 rand or kilogram per cube for concrete reinforcement. We might need a 150 kilograms per cube. What will be the implications thereof? Where do you have to apply all of that? Or you have to change the design from a normal strip foundation to a raft foundation. Will that take the price up or will it take it down? Those type of items you need to interpret. The estimator's understanding of the building cost, use of cost, etc. Will the cost that you retrieve from a supplier be what type of markup will you put on top of that if you need to do a grade buildup? The ability of the estimator to apply different methods appropriately. Completion of the project information received. How complete is the information, which I've already spoken about. The number of variations during the estimate or estimation period. How many reviews have you had with the client? Or even during the construction, how many variation orders do you foresee might happen on this project? And then obviously your regional influences might differ as well. So let's get into the single price methods. And as mentioned, you already covered this, so I'm not going to spend a lot of time on these items, but it's worthwhile just going through it so that you can actually have good discussions between how your single price methods compare against your single price detailed methods. Okay, so we've got our three basic single price methods, which is our unit method, our area method, and our cube method. They are simple estimations and do not take a lot of time and not as accurate as other methods. You can obviously improve the accuracy of these methods by inquiring about or improving your rates that you use, excluding external works and calculating that maybe in detail, etc., etc. So our single price methods, okay, this is just a repetition of what I've basically done. You use your historical data to calculate your tariffs. So you would take old projects and see what the cost of those items were per unit, per square meter, or per cube. They are limited and entail the allocation of simple tariffs. So we've got our unit method, our area method, and our cube method. So our cube method, remember there's a specific formula and it's actually included in your reading work. I will add that slide onto your estimate or that item here on the slide so that you can just refresh your memory of how that is actually done. So that is where you use your trigonometry to actually calculate um, the height of your building. The square meter area was quite easy to calculate. I think the biggest challenge usually was to establish from where does your height start and where does it end. So um, I'll maybe just add that on an extra slide for us. Okay, so pardon everyone, I think I've recorded over the wrong slides, but in this slide, one just looks at the what is a unit? It's a discrete portion into which something can be divided. A standard measurement denoting a quantity, e.g. Meters, kilograms, degrees, or volts or hours. But a single element or component is used for your unit method. So it usually includes many of these items for your quantities, and it's specified. A specified portion is included in this unit that you use. So some examples that one can have a look at is arcades, churches, etc. that I've mentioned before. You will see movie theaters is also example, hotels. Okay, so the unit method is you take your past historical data and then you determine the total cost for that historical building by dividing it by the unit that I've mentioned in the previous slides. So then you calculate the tariff and improve that cost. If you've worked on the project maybe 2 years ago for your historical project, you will apply some sort of escalation on those rates that you used or that you got there to get to a more accurate rate. Did the previous historical data, does it compare well with this new project that you're going to tackle? So the applications useful, it's useful in the initial stages of the project, okay, and it establishes the extent of the developer's cost. So it's just, it gives a nice budget that the client can aim for. Preliminaries and determination of cost goal and the cost limit. So it just gives you a preliminary determination. So the advantages of it, it's quick, it's simple, and few material calculations is needed. It's suitable for the establishment of a cost standard as a guideline for planning. Obviously, this brings about that it's not that accurate, large deviations from accurate and final values. The adaptation of historical unit tariffs is difficult and requires considerable understanding and experience. So experience is extremely important when using this method. And the historical unit tariff are only valid for a short time. So looking at the practical example, we've got our old office building where we had 8 offices and we have a new building where we have 4 offices. So you want to try and compare apples with apples. You can see immediately there's some differences in this that we'll look at when we get into the examples proper. But you can see immediately that there's more paving in the new building. There's 2 conference rooms instead of the only one in the historical building. So you can tweak your cost by omitting or including some of these items. So let's look at our previous historical building. So you can see it had a cost of 3.9 million, but whenever you do work with your base units, you always subtract your P's and G's and your VAT Otherwise it will cause a error. If you are inaccurate with your estimate, it will just exaggerate your mistake by including this early on. So you want to break it down as into such a small unit as possible whenever doing your estimate. So, but it's very simple. You take your historical data, you exclude your P's and G's, and you divide it with your 8 offices. You get your rate per 8 office of rate per office, and you times it with your new building's number of offices to get, and then you will add your contingencies depending on how confident you are with your estimate, and you will add your P's and G's as well as your VAT to that to get to your new estimate. So very important, it's make sure that your historical data has the same future items as proposed. So you could see that I've highlighted immediate differences in the drawings, which will give you ample discussions whenever I do ask a question like this. What items would you suggest to include or to exclude? For example, if the historical building has cost data that includes mass earthworks, preparing a platform for your building to be constructed on, it's better to calculate that separately. And remember to calculate your historical tariff on the construction cost, excluding your P's and G's, contingencies, and VAT. Okay, then you can have a look at your some additional work. I've included the construction property and construction guideline cost, so the newest rates that's available on Blackboard View. So just take note of these items. Look at items per key or per seat, per inmate if it's a jail, per parking, etc. But always read the fine print at the bottom. The hotel rates include allowances for furniture, fittings, and equipment. So you don't have to go and include that now additionally to your estimate. Also take note at the beginning of these rates where it's applied, it also indicates what is included. For instance, parking or exterior work is excluded in these rates. So just make sure what to use and what is not, what you should exclude. Okay, here's the video that I've spoken about. You will see there is the link to this video. Then we get to our area method, and it's very similar to your unit method. We just calculate this the rate per square meter instead of per unit, and it's most commonly used in the industry and can be applied to all building types. That's the advantage of this, as well as it's easily understood by the client. So it's basically just your building area times your tariff or your rate that you've calculated, and according to this method, the total floor area of the planned building is determined and suitable area tariff is then allocated, the product of which represents the estimated building cost. Obviously, you need to still add your extra overcost, etc. What is construction area? So it is the purpose of this building estimate. The construction area includes sum total of the area for each covered floor level. So each floor area has to be measured separately over the outside of the walls. Very important to remember that. And in the residential class, I've mentioned that if you've done extensive measurements and now you get to a point where you need to compare this to your new building, just make sure that you compare apples with apples. So if you've mistakenly measured your historical building to the inside of your building, just make sure that you apply that to your new building as well, so that you don't make that mistake. Obviously, if you've got time and you want to improve your estimate, always measure to the outside of the building, because people will compare that rate per square meter to what they've heard in the industry or seen on the internet or so, and that estimates are usually based on the building area to the outside of um, the perimeter or the wall area on plan. Okay, so where do we get the definition of the term construction area? It is from the Elemental Guide, and see the definition sections at the beginning of the document. Okay, so you can just have a look at that. That is study the definitions used and continuously throughout this module. So when you do go through your Elemental Guide, please make sure that you read through that introduction section, what is included in your units and what is not. So it's extremely important to have a look at that. So your area method, the following items should specifically be excluded from your calculations: your steps, paved areas, areas projecting over roof overhangs, hoods, canopies, and the like, enclosed open areas like ventilation well courtyards, areas of open covered walkways, areas of unenclosed fire escapes, areas of on plan of small projections such as pilasters, attached piers, fins, chimneys, etc. The main thing about this is to make sure that you compare apples with apples, hence again the repetition of what I've said already. So your area method, the area tariff is obtained from the past projects as mentioned, and you divide your previous project with this area that you calculated, and then you get an average historical tariff which is applied to your new building. So the historical building should be comparable to the plan in regard to the building type, the type of structure, size, shape, height, general details, specification levels. So obviously you're not going to use the rate per square meter for a nuclear plant whenever you're designing a new house. So you need to make sure that you try and keep it as accurate as possible for that that estimate. And always very important, once you've done your estimate, always compare it again to other items, for instance the AECOM report or what you've seen in other projects. Don't just compare it to one project. Um, Look at whether it makes sense or not. It's paramount that you do that in your estimation. Okay, and this is just a repetition. Okay. So the advantage again, it is simple, it's fast. The method can be applied very early on in the project life cycle. It's more accurate than a unit method. It can easily be used for cost comparisons. You can easily build up a library of previous work, and then any type of building can be used for this. The disadvantages of course is it's not that accurate because it's still a single price method. It doesn't take into account your floor to ceiling heights and requires understanding and experience. So looking at the example, you can see it's the same building that we've used previously. Same principle applies, where you take your historical data and you divide it with the total area that you've got here. So you exclude your P's and G's, VAT. If you had contingencies, you exclude that as well. And you divide it with the total area to get a rate per square meter, which you apply to your new building. So increasing your accuracy here would be if you see, but you're working on a high-end finish project on your previous project, you can lower your rate slightly. Or if you know that, okay, we've moved away from Cape Town, for instance, and now we've moved into Bloemfontein, for instance, now it might be a little bit cheaper, so you can reduce your rate as well. Where it's not a high-end finish office building, or maybe the client will do the ICT installation himself, so then you can make relative adjustments to this. Okay, and then you just calculate your base rate, your basic building cost, and you add your P's and G's, your contingencies, and your VAT to that. Okay, and then just again the extract, I think this one was just included mistakenly. This should actually be all of the per square meter rates. There's quite a few of them, and again, just make sure what is included, what is not in the fine print. Okay, then finally we get to our unit cube method, and let me just quickly add that additional slide that I was talking about earlier. Okay, we're back. Okay, I've added that slide for you. So whenever you're working with your cube method, I think the easy items will be your width and your length. Just remember that if you're working with a multi-story building, it's the height that you're working with. So it might be conducive to break it up, but you always work with your total height of the building. So you take your height above your strip footing up to the middle of a pitch roof for your height. So this is for a single story building. With if you've got a construction or a concrete roof, you will do the same from the top of your strip foundation and then 600 millimeters above your concrete roof. Again, the objective of this is to compare apples with apples. So if you've got a double volume where there is no construction in a certain area, like a lobby area or so, you need to exclude that and maybe calculate it differently, or you need to use that lobby area cube rate only on a lobby area in your new building. So very important to break that up, and that is usually the reason why the cube method hasn't really taken hold that much as the square meter area, for instance. If the unit or and area method is the least accurate um, of all the single price methods, which one is the most accurate? Okay, it is the cube method, because you're now adding another parameter. So the more parameters you add, the more accurate your estimate can become. But as mentioned, this is not without its downfall, because you have to apply your mind whenever you do use the unit method, because it really does differ from project to project. If you're working on shopping malls, you've got higher ceilings, so you need to account for that. If you've got new historical buildings with the same sort of volume included per floor, then it is quite an accurate method to use. But it adds a additional dimension which you have to account for. So yes, it can be more accurate, but it depends on the applicant how accurate it will be. So the method is based on the cubic content of the building. More detailed is used than the previous methods. And then the cost per cubic meter method is specific for building projects and aims to overcome the current circumstances or criticisms of the area methods. Okay. So in short, it's basically your volume of your building times the volume of your or volume tariff for your new building to get a new cost. So the volume is usually the external plan area times the height times the area of your project. And as mentioned, you need to compare apples with apples again. You need to make sure that you um, use the same parameters on your historical data when you calculate your tariff when it is applied to your new project. So the total volume of the planned building is determined in which the suitable volume tariff is allocated so as to determine the total estimate cost. The height of the building entails the vertical height as the measurements from the average top level of your strip foundation to the center point. So that's that formula that I've spoken about. The historical cost is divided by the building volume so as to obtain the volume tariff. So, and the advantages is it's still simple and quick to complete and interpret, more accurate than the previous methods. Simple math is required, and the method can be useful during the initial stages of the project. It is not as accurate as the more detailed methods, Due to the large number of variables, it is difficult to adjust the unit cost, and it fails to take into account variations in plane, shape, story heights, number of stories, etc. Because if your height might be similar on a project, but you might have a mezzanine floor on your historical building, which is not included in your new building, which will throw out your historical tariffs. So you need to consider that whenever you do your calculations. So your estimate needs more experience and skill to apply, as evident from the previous slides. So the practical example is again our historical office building and our new office block. So looking at our total cost, we calculate what our volume of the project is. And you can go through this. I think you have done this already in the previous years, but please make sure um, how to calculate your vertical height on um, on your building so that you can compare apples with apples. Okay, so we've calculated here our conference rooms and our offices, and now we got a total volume of 1,138 cubes. We divide our project cost, excluding the VAT, excluding the P's and G's, to get a cost per volume, and then simply apply it to our new building. We calculate the total volume of the project of our new building, and we times it with our tariff, and we again add our P's and G's, our contingencies and VAT to this project. Okay, so very short, very simple, break it down to easy recognizable discussions where think already about how can you improve your unit tariffs if you don't have enough information or so. So please make sure that you understand how all of these methods work. Thank you, everyone. That is the lecture 2, basically still very much an introduction. From the next lecture onwards, we'll start getting our teeth into the meat of this module. Thank you. Bye.